So we're going to talk about double angle formulas and half angle formulas and product of sum formulas. So we've got a lot of formulas in this section. So here we have our double angle formulas. They come from the addition formula, just to give you some knowledge. We've got sine of 2x, cosine of 2x. Cosine of 2x has three formulas you can choose from. One that has cosine and sine, one that has sine only, and one that has cosine only. So depending on what you're given, you can use those formulas, the right formula to get what you need. We also have a tangent of 2x. We have lowering power formulas. We have half angle formulas. We have product to sum and sum to product formulas. So we have a whole list of formulas we're going to use in this section. Alrighty, so let's go to our first example. So we're looking to see that if the cosine of x is equal to negative 2/3 and x is in quadrant 2, we want to find cosine of 2x and the sine of 2x. So we're going to find two things. So the first thing we're going to find is the cosine of 2x. Now, we only have the cosine formula, or the cosine value. So for our cosine, we can't use the first one, we can't use the second one. We can only use this third formula because we only have our cosine given to us. So this will be equal to 2 cosine squared x minus 1. So that's going to be 2 times negative 2/3 squared minus 1. So negative 2 squared will get us 4. 3 squared will get us 9. So this will be 2 times 4 is 8 over 9 minus, I'm going to write 1 as 9 over 9. So we have a common denominator. And we will get negative 1 over 9. All right, so we found that part. Now let's go find the other part. So we can look at finding the sine of 2x. Now, in order to find the sine of 2x, when I go look at my formula, I have to know the value of sine. I need the value of sine. I can't find the sine of 2x until I have that value. So how do we find the value of sine? Well, first of all, we're going to have to use our Pythagorean identity. So we know that let's come down here and do that. So we have the sine of squared x, sine squared x is equal to 1 minus cosine squared x, because that comes from the Pythagorean identity where we can, we have that right here, we just move cosine squared over. This is one that's very common that we're using a lot in our proofs of proving one side equals the other side. So you need to recognize these things. So to solve that for sine, I'm going to take the square root of both sides. So my sine x would be equal to plus or minus that square root of 1 minus cosine squared x. But we know we're in quadrant 2, so I know it'll be positive. So the sine of x would be equal to square root of 1 minus our cosine value. And our cosine value is equal to negative 2/3. So this will now be, this is going to turn into 4/9, so I'm going to write this as 9 over 9 minus 4 over 9. So that will get us the square root of 5 over 9, which will become the square root of 5 over 3. So now that we know the value of sine, we can go do our formula up here. So the sine of 2x is equal to 2 times the sine of x cosine of x. So 2 times the square root of 5 over 3. times the cosine of negative 2 over 3. So 2 times negative 2 will get us negative 4 times the square root of 5, and 3 times 3 will get us 9. So this would be the value of sine. This is the value, or the value of sine of 2x, and we have the sine of 2x, or the cosine of 2x we found already. So sometimes you're going to have to go find some parts. You're still going to have to use the knowledge that you know previously in order to solve these. So let's go look at our next example. So we are going to write the cosine of 3x in terms of cosine x. So we want to write it just in terms of cosine. So this goes back to what we did in the previous section when we had angles that were like 75 degrees and finding the value. We're going to have to break these up. So we're going to have the cosine of 3x is equal to the cosine of 2x plus x. And this will get us an s and a t. Now that we have that, we can use the addition formula for cosine. So this will be the cosine of 2x cosine of x minus sine of 2x sine of x. So this is coming off of our addition and subtraction formulas that we used right here. So we're using our cosine addition formula there. Even though now it becomes subtraction, that's kind of how they work. All right, so what I'm going to do is look at more of what I have. I have a double angle here and I have a double angle here. So I'm going to use my double angle formulas. So I have the sine of 2x and I have cosine of 2x. For the cosine of 2x, I'm going to use the last one, and then I'm going to use that sine of 2x. You do have a couple of choices, but remember, we want it all in terms of cosine, right? So that only tells me to use that one. That's how I'm going to choose that one, because it has to be all in terms of cosine, so why not just go there? All right, so this would be equal to 2 cosine squared x minus 1, because that's what the cosine of 2x is equal, times our cosine of x. So I'm putting parentheses so you can see it's both terms. The sine of 2x becomes 2 times the sine of x cosine of x times our sine x. So we've rewritten our double angles into terms that are in from the double angle formulas. So now let's distribute. We're going to go ahead and multiply our cosine times both of those. So we have 2 times the cosine cubed x minus cosine x. So that's just distribution. We're going to do the same thing here. We're going to multiply it. It's not really distribution here, it's just multiplying. So this sine gets multiplied by that sine, and we will have 2 times the sine squared x cosine of x. Now, sine squared x, we just used that in a previous problem. Sine squared x would be equal to 1 minus cosine squared x, because I got to get rid of that sine. I want it all in cosine. So this will be equal to 2 times our cosine cubed x minus our cosine x minus 2. I'm going to move our cosine up front and then put this as 1 minus cosine squared x. So our sine squared x now became this. And I'm going to distribute again. So 2 times cosine cubed x minus cosine x minus 2 times cosine x, because that's times 1, and cosine times cosine will get me cosine cubed, but I also have to multiply by the 2. And negative times a negative will make that positive 2 cosine cubed x. So now we have some similar terms. We have 2 cosines cubed, and then we have 2 negatives on our regular cosines. So 2 plus 2 will get us 4 cosine cubed x minus 1 minus 2 will get us minus 3 times the cosine of x. And that's how we can write that in terms of cosine from that triple angle. All right, let's go look at another problem. So we are going to prove an identity. The sine of 3x over sine x cosine x is going to be equal to 4 times cosine x minus secant x. So we have to see which side is the most difficult side. I would say this is the more complicated side, but I want to rewrite this in terms of sine and cosine. So understand that this is equal to 4 times cosine x minus 1 over cosine x, so that when we're moving this around, we know what we're trying to get to. All right, so let's take our left-hand side, which is equal to our sine of 3x over our sine of x cosine x. So this is rewriting this like we did earlier. I'm going to write this as the sine of x plus 2x. And again, you could write it as 2x plus x. It doesn't matter. Either way will get you there. All over the sine of x cosine of x. All right, so let's distribute this. Oh, sorry, not distribute. Let's use our addition formula. We just factored it. So we're going to use our addition formula for sine of s plus t, and we will get the sine of x cosine of 2x plus the cosine of x sine of 2x. And if you're struggling to follow these, pause for a minute, go look at your formula, because we've got our sine of x plus 2x. Oops, that's the addition, sorry. So many formulas, I'm telling you. So it'll be the sine, cosine, cosine, sine. That's just how the formula is. So you're wondering, where is she getting all this? It's coming right off our formula of s plus t. And this is our s, and this is our t. You've got to understand how those are going to work. And this will all be over our sine of x cosine of x. All right, now we have two double angles, right? So we've got to take care of those double angle formulas. So now we'll have the sine of x. Cosine of 2x is going to be 2 times cosine squared x minus 1 plus cosine of x, sine of 2x. That's going to be 2 times the sine of x cosine x. Still all over sine x cosine x. So what we're going to do now is let's split our fractions. I can see I could get rid of sine if this was right here, not together. And over here I could get rid of cosine if they were not being added. So let's split the fraction here. So the sine of x times 2 cosine squared x minus 1 all over sine x cosine x plus the cosine of x times 2 times the sine of x cosine x all over sine x cosine x. So now I can do some canceling. So I've got sine over sine, because it's all multiplication at this point right here. And over here we have multiplication as well. I have sine will cancel and the cosine will cancel. Over here I still have that too, but it's all multiplication. So it doesn't matter which cosine you take care of, it will all be just fine. So now I have 2 times the cosine squared x minus 1 over cosine x plus I have 2 cosine x, because that's what I have. I have a 2 and a cosine of x left right there. Well, let's split this fraction here. So now we have 2 cosine squared x over cosine x minus 1 over cosine x, because I just split this fraction here, and then plus 2 times cosine x. All right, so here I can cancel cosine x out of that squared. So that will leave me with 2 times cosine x minus 1 over cosine x plus 2 times cosine x. Well, those two cosine x's, those will add together and get me 4 times cosine x minus 1 over cosine x. If you notice, this now equals what we said this side would need to equal. And by writing this as cosines, I knew that somewhere in there I had to clear out all of my sines. And now I can say that 1 over cosine is equal, I'm going to write it right here. So 4 cosine x minus secant x. And this equals my right-hand side. So we have proven this. So some of these are going to take a little bit of effort and a little bit of practice, but you can do it. You just got to spend some time with them. All right, let's go look at a lowering powers formula. So that's these formulas here, and it takes us from a squared down, and notice they become double angles. So there's going to be a little bit in here to do, but we're just going to take it one step at a time. So we are going to express sine squared x cosine squared x in terms of cosine x. So that tells us we need to move everything into just cosine. No sines, so we're going to have to get rid of all of our cosine. All right, so let's go look at our solution. We have sine squared x cosine squared x. Well, the sine squared x, according to the lowering powers formula, will be equal to 1 minus the cosine of 2x all over 2. And the cosine squared x would be equal to 1 plus cosine of 2x all over 2. So both of our formulas end up taking us all the way to cosine. So we're good there using those lower powering, but we've got to simplify this out. We can't go, oh, we're done, and we have not cosine x, we have double angles. So let's go ahead and do some multiplying here. If you remember your college algebra, 1 minus something times 1 plus the same thing is the difference of squares. So if we FOIL that or distribute it, we're going to get 1 minus our cosine squared of 2x all over 4. So think about that as being difference of squares. So you're just going to square both parts there because they get multiplied by themselves. The middle terms would cancel. Now what we're going to do is let's separate into or split it into two fractions. So we'll have 1/4 minus cosine squared of 2x over 4. So I'm splitting my two fractions. Now what I'm going to do is write this as 1/4 minus 1/4 times my cosine squared of 2x. So that way I've got that 1/4 kind of out of the way. This is a double angle. So we are, but it's also a power formula. So we want to lower that power down, back down to cosine. So I have 1/4 minus 1/4 times, this will be 1 plus cosine, and it's of 2x. Let's go look at our lowering power formulas. It becomes a tongue twister at some point. So it's 1 plus cosine of 2x, because normally that's x, but because we have an angle of 2x, it's going to be, because of the formula, there will be a 2 and there will be a 2x there. So it'll be cosine of 2x, but our x is actually 2x from there. And then that's all going to be over 2. So what I'm going to do is move that 2 out here, but I'm also going to multiply 2 times 2x. So 1/4 minus, so this 2 gets multiplied by that, 1 over 8, so I just multiply by the denominators, but I want to keep it out of there. And then I have 1 plus the cosine of 4x. All right, now I have a 1 and I have a cosine of 4x there. So what I'm going to do is distribute that 1/8. So it'll be 1/4 minus 1/8 times 1, and then minus 1/8 times the cosine of 4x. So I need to get common denominators here. So this needs to be 2/8 minus 1/8, minus 1/8 times the cosine of 4x. Well, 2 minus 1 will get us 1/8 minus 1/8 the cosine of 4x. Now, in some instances, they're going to want you to factor out the 1/8. So we'd have 1/8 times 1 minus the cosine of 4x. That's what a lot of the books will see as the final answer, but I don't know that that's a wrong answer. This one is a lot of steps for the lowering powers, so just be aware of that. So let's move off of this one and let's go to the half angle formulas. This one may seem a little bit easier. This has a lot of shifting things around because of all those denominators. All right, so we're on to our half angle formulas. So that means we're going to have a u, an angle, divided by 2 is equal to this. We've got 3 different formulas here, and this is equal to this, which is equal to that. So either just depends on what one we're doing to what we'll need to use. So we want to find the exact value of sine 22.5 degrees. So this is not a whole angle, this is a half angle because it's got a half. So the first thing we're going to do is multiply 2 times 22.5, and that'll get us 45 degrees. So 45 degrees, that's going to be in quadrant 1, so we know that it's going to be positive, and we're going to state that that u would be equal to that, because that's our angle. We need to have an angle that we can use. So this will be the sine of 45 over 2, because that's the same thing as 22.5, will be equal to that square root of 1 minus the cosine of u, which is cosine of 45, all over 2. That's using the formula. So this will be the square root of 1 minus square root of 2 over 2 divided by 2. So like we did in the last problem, I'm going to pull that 2 out by making it a 1/2. So this will be the square root of 1/2 times, I'm going to make that 1 have a common denominator of 2 over 2 minus the square root of 2 over 2. I think I got a little small on that, sorry about that. I'll write a little bigger. So the square root of 1/2, so this will be 2 minus the square root of 2 all over 2. So I got a common denominator. 1 could be anything I need it to be, so I could subtract those together. Now I can multiply this. That'll get me the square root of 2 minus the square root of 2. 2 times 2 is 4. Well, I can separate what I have because 4 is a perfect square. I can change this to the square root of 2 minus the square root of 2, and the square root of 4 will get us 2. And this would be the final answer. It's an ugly answer because you got double square roots, but that would be the value. It's the exact. The exact, when we're looking at exact, we're not looking at decimal answers at all. So be aware of that when you are doing your homework and when you are studying for your exams, to keep those very, very clear. All right, let's go to a half angle. So let's find the exact value. Oops, looking at the same problem, so sorry. So let's find tangent u over 2 if the sine of u is equal to 2/5 and u is in quadrant 2. So we need to find the cosine in order to do tangent, because when we look at our tangent formula has cosine and sine, and we don't have the value of cosine, we only have it of sine, so let's go find our cosine. So you know from the Pythagorean theorem, because we've talked about this a couple of times, that the cosine of u will be equal to that square root of 1 minus sine squared u. We've talked about this several times, and we know because it's in quadrant 2 that our sine or our cosine will be a negative value. So this would be cosine squared u is equal to 1 minus sine squared u, but we are going to take that square root of it. So this will be negative square root of 1 minus, our sine is going to be 2/5 squared. So this will end up being 4 over 25, so I'm going to write my 1 as 25 over 25 minus our 4 out of 25. So negative the square root of 21 over 25. Now that square root of 25 we can take, so it'll end up being negative square root of 21 all over 5. So now we can go find our tangent u over 2. So the tangent of u over 2 will be equal to 1 minus cosine u over sine u from our half angle formula. So this will be equal to 1 minus our negative square root of 21 over 5 divided by 2/5. So we got to get a common denominator again. So 5 over 5 minus, plus, negative be positive, square root of 21 over 5, still divided by 2/5. So this will get us 5 plus the square root of 21 over 5 divided by 2/5. We don't divide by fractions, we multiply by reciprocals. So we'll have 5 plus the square root of 21 over 5 times the reciprocal of 5 over 2 there. Our 5's will cancel, and we'll end up with 5 plus the square root of 21 all over 2. And that would be our final answer for that one. All right. So now we're going to go do some product to sum and sum to product formulas. There are a lot of formulas. Not even going to lie about that. This is why I will give you a formula sheet that is labeled. All right, so here's our product to sum formulas, and then we have sum to product. So we're going to use those in the next examples. We have 2 more examples. All right, so we are going to express the sine of 3x, sine of 5x as a sum of trig functions. So this time we're not being told to express it just as sine or cosine. It may end up that way, but it'll be fine. All right, so the first thing you have to realize, this one they do as u and v instead of s and t. I'm not sure the difference, but sometimes they just like using the different letters. So we need to know what our u is, what our v is, and we also need to understand that cosine is an even function and sine is an odd function. That will come into play here. So our u comes first, so this will be our u and this will be our v. So u is 3x and our v is 5x, and I'm going to write cosine is even function because we have to use that in this problem. All right, so that means we have the sine of 3x sine of 5x will be equal to 1/2 times the cosine of u plus v, or sorry, u minus v, so it'll be 3x minus 5x minus the cosine of 3x plus 5x. So let's simplify this. We'll get 1/2 the cosine of negative 2x minus the cosine of 8x. Now, cosine is an even function, so that means that negative sign gets absorbed into it because it's like a x squared type of function. So we'll have 1/2 times the cosine of 2x minus the cosine of 8x. So that's a respectable answer. And in some cases, they're going to want you to distribute this way. But there's nothing wrong with that answer. Again, it just depends on what your instructor is looking for. So sometimes they want you to distribute that. Do not divide this into those. That's not the same. You can't, that half doesn't clear the 2 or the 8. They are separated. All right, so let's go do our, I believe, nope, we have 2 more examples. All right, so we are going to express the sine of 7x plus the sine of 3x as a product. So this is a product to a sum. Now we're going sum to product. So again, it's about matching our formulas. So 7x plus the sine of 3x, you've got to look for a u plus a v that have signs. So we're looking at the sum to a product. So here we have sine plus sine, and this one's xy, not uv. So this will be our x and our y. It'll be equal to this. So you just match what you're looking at to what is on your formula sheet there. All right, so this will be equal to 2 times the sine of 7x plus 3x over 2 times the cosine of 7x minus 3x over 2. So this will be 2 times the sine. 7x plus 3x will get you 10x over 2 times the cosine of 7x minus 3x will get you 4x over 2. So 10 divided by 2 will get us 2 times the sine of 5x. 4x divided by 2 will get us cosine of 2x. And that's your final answer right there. So some of these will go a little bit faster than others. All right, let's go look at our next example. And it should be our last one. So we are going to verify that the sine of 3x minus the sine of x over the cosine of 3x plus the cosine of x is equal to tangent x. So this is where we're going to have to do a left-hand side and a right-hand side. But the first thing I want to know is, I know this is the more complicated side, so I'm going to start here. And tan x would be the same thing as sine x over cosine x. So let's go do our left-hand side to start with. So the sine of 3x minus the sine of x over the cosine of 3x plus the cosine of x. All right, so we've got a triple angle here, but we're more looking at 3x because we're using our addition and subtraction, our sum to product. We know it's got to get to a single term. So if I go look at my sum to products, I'm looking at sine minus sine, So it's going to be 2 times the cosine. And let's see if that angle might shrink down when we do some adding and subtracting and then dividing by 2. So this will be using the formulas we're using in this case, which is our sum to product, sorry. Too many formulas. So this will be 2 times the cosine of 3x plus x over 2 times our sine of 3x minus x over 2 divided by 2 times our cosine of 7x plus x over 2 times the cosine of 3x minus x over 2. All right, so this will get us 2 times the cosine. 3x plus x will get us 4x over 2 times the sine of 3x minus x will get us 2x over 2 all over 2 times the cosine 7x plus 7x. Sorry, that's not a 7, that should be a 3. So sorry. So 3x plus x will get us 4x over 2. And then this will be the cosine. 3x minus x is 2x over 2. So this gets us 2 times our cosine. 4x divided by 2 will be 2x. Sine of 2x divided by 2 is x. 2 times our cosine. 4x divided by 2 is 2x, and cosine of 2x over 2 is cosine of x. Well, we can see the 2's will cancel, and the cosine of 2x will cancel with the cosine of 2x. And that just leaves us with sine x over cosine x, which is equal to our tangent of x. So sometimes it looks like it's going to be really complicated, but it'll shrink down pretty quick. So you don't have to memorize the formulas, you just need to know how to use them, and you need to be aware of them.